Hi everybody, here's our quiz number 12, and we're starting to wind down in the semester, and we're talking about pressure here. So the way we're going to do this video is I'm going to walk through the problems, but I'm not going to go through all the details of the calculations. If you want to see all of the details and how they're worked out step by step, I would ask that you refer to the worksheet number 12 video, where I do all of the calculations in great detail for each of the problems. So here I'll just show you how I would do them, but I won't walk you through all the steps. So let's go ahead and get started. Here on number 1, which of the following pressure measurements is equivalent to 1 atmosphere? All of these are equivalent to 1 atmosphere. These are just by definition. So all of the above is the correct answer for number 1. And then for number 2, we're being asked to convert 352 torr into kilopascals. Well, what we have to remember is that there are 760 torr in 1 atmosphere. Okay, and so then there are also 101.325 kilopascals in an atmosphere. So what we can do is we can use this conversion and say, we'll just get rid of the atmosphere and say there are 760 torr in 101.325 kilopascals. And what we can do with this now is use this as a unit conversion and say, well, we don't have 760 torr. Instead, we only have 352. So now 352 torr is what we actually have. And we can apply a unit conversion here to get us into kilopascals. So 101.325 kilopascals divided by 760 torr. Now our torr cancels, and the units we're left with are in kilopascals. And when I do this on my calculator, I get 46.9 kilopascals. So A is the right answer for number 2. And now let's move on to number 3. And so for this problem, I'm going to go ahead and write out the solution and just let you see that, but I won't take the time to go through all of the steps. So once again, if you want to see all the steps for a problem like this, go ahead and refer to worksheet number 12. That's where I walk through all of the steps. Okay, so in number 3, the correct answer was 958 torr, so B is the right answer. And now let's move on to number 4, where we've got a few different gases, hydrogen, air, and nitrogen. And suppose these gases are at standard temperature and pressure, and we had a liter of them. Which one contains more molecules? The hydrogen, the air, the nitrogen, or do all of them contain the same number of molecules? And so the key thing here is that we're talking about STP, and even though it wasn't explicit in the question, I think it's pretty fair to assume that we're talking about ideal gases here, since that's the context of our discussion with gases so far. So an ideal gas is always going to follow this proportion. 1 mole of an ideal gas is going to occupy 22.4 liters. Right? So if we have 1 liter, we can do it like this. 1 liter of the gas, I can say ideal gas, times, we can now use this proportionality here, times for every 1 mole of the gas, there are 22.4 liters. We would conclude that a liter of an ideal gas contains 0.0446 moles. And the reason I generalized it to an ideal gas is because it doesn't matter what the gas is. The important part is that the gas is an ideal gas, and as long as that gas is at STP, it will always have the same number of moles if you have a liter of it. So a liter of any kind of a gas will always have 0.0446 moles because of this relationship here. So 1 mole is going to have 22.4 liters. So what we're showing here is that it doesn't matter what the gas is. If you have a liter of it, you're always going to have 0.0446 moles of it. And so obviously, if you have the same number of moles of a gas, then you must have the same number of molecules. So we're showing here that a liter of any ideal gas is always going to contain 0.0446 moles of that gas, which then means that if the moles are the same, then that means that the number of molecules is going to be the same as well. So D is the correct answer for number 4.